Good morning. My name is Jacek. I am a researcher at the Krakow University of Economics. I work together with my colleagues Jacek and Olga HNATYSZAK in the College of Management and Quality Science in the Institute of Quality Science and Product Management. Our work presented here discusses a method for recovering energy from alkaline batteries to be recycled. The use of compact electronic devices with batteries, such as remote controls, watches, electric toys and pocket torches, has become an integral part of our society. Due to the growing demand for primary cells worldwide, the global market for such products is expected to maintain an upward trend over the next 15 years. Following the production results from 2007 to 2015, a marked increase in production and demand for primary batteries was observed. In the period, the market reached record production levels. The market's performance is expected to continue its upward trend in the coming years until at least 2030. Poland, in terms of the number of enterprises producing primary cells and batteries, is in the third place in the European Union after Germany and Italy. From 2009 to 2018, sales in the battery industry increased by 282% in Poland, and in terms of turnover achieved, Poland is the fifth country in the European Union. The industry is steadily increasing employment. In employment terms of trends involved in the production of batteries and accumulator, Poland is the second country in the European Union, right after Germany. Primary batteries have a finite lifespan, so the increasing number of used batteries over the past few years calls for an innovative approach to the disposal process. Used batteries containing chemicals such as zinc, mercury, manganese can negatively impact the soil and pollute water if not properly collected. It is still very difficult to quickly deal with this type of waste, and it is a serious environmental problem. The undertaking of this research topic was motivated by authors' observation of the energy waste associated with not fully discharged primary cells being recycled. The authors' previous research done on batteries collected from waste battery collection points showed that it can be found about 30% of primary cells from which the energy stored in them can be recovered. The studies carried out in Poland show that from these 30% of batteries have on average up to 45% of stored energy. Classic recycling process do not include the element of sorting batteries by degree of discharge, and the whole process of raw materials recovery is the same for each type of battery to be disposed. Hence, the use of the remaining, underutilized energy in products such as cells and batteries may prove to be a complementary method to recycling. The present study shows a solution leading to the energy recovery from used primary cells, which, according to the consumers, are no longer useful. Before subjecting the batteries to raw materials recovery, it will be possible to fully consume the energy from the used cells, increasing the environmental aspect of the whole process of recycling. Basing on our research, we propose a recovery method that is based on increasing the voltage of discharged batteries by using a step-up converter. With this solution, it is possible to extend the life of the batteries and thus extract from them more energy than with traditional methods. We have carried out comparative studies using a laboratory bench of our own design and presented the benefits of this type of solution. We also describe a proposal for the recovery of electrical energy from partially depleted alkaline primary cells, with the possibility of its transformation into AC current and voltage, with parameters consistent with those required for powering household devices. Such parameters were obtained by using an inverter. The benefits of such solutions are shown graphically on the characteristics made with both variants of battery connection. In this figure, you can see performance characteristics of a partially depleted battery pack in energy recovery without the use of step-up converter. And here we can see performance characteristics of a partially depleted battery pack in energy recovery using a step-up converter. As a result of conducted research, it was proven that the use of the step-up converter allows better utilization of depleted primary cells. Measurements taken during the study showed that the use of this converter increased the operating time of the tested primary cells by 23% compared to a system in which such a converter was not used. The use of a step-up converter and inverter allows the energy stored in the used alkaline primary cells to be directly fed back into the 230-volt mains. Thanks to the presented solutions, it is possible to recover part of the electrical energy from depleted primary cells during their recycling. This has a positively impact the economic aspects, as the process of primary cells disposal generates energy-related costs. The recovery of electrical energy from primary cells could also have a positive impact on the environmental balance, as it will reduce the energy required for the disposal process and thus reduce CO2 emission into the atmosphere. Thank you for your attention. For more, please see the entirety of our research described in the article.